Somewhere in the sawgrass south of Naples, Florida, a radio signal stops moving. That is the entire event at first. No alarm, no gunshot, no splash. Just a blinking dot on a biologist tracking screen that used to shift a few hundred yards a day, and now doesn't shift at all. To understand why that stillness mattered, you have to understand what was wearing the tracker. Not a bird, not a deer, a 13-foot Burmese python, one of the largest invasive predators on the North American continent, an animal with almost no natural enemies anywhere in the state of Florida. And when researchers finally reached the signal, they didn't find a python. They found a headless one. This is the story of that snake, the animal that killed it, and the much bigger, much stranger war that killing represents. A war between an invasive species that has already devastated the Everglades and a native ecosystem that may finally be learning how to fight back. The python's name was Loki. He was a scout snake, a male fitted with an implanted radio transmitter by researchers at the Conservancy of Southwest Florida, a non-profit science and conservation organization that has spent more than a decade tracking Burmese pythons across the region. The idea behind the Scout program is simple and a little brutal. Male pythons are drawn irresistibly to breeding-age females during mating season. So if you tag a male and follow him, he will often lead you straight to a much larger egg-laying female, the kind of snake capable of producing 50 to 100 eggs in a single clutch. Find her before she nests, and you may have just prevented an entire generation of pythons from ever hatching. In December 2022, the Conservancy's lead field biologist, Ian Bertashek, and his research partner Ian Easterling were tracking Loki's signal, expecting the usual outcome. A big male curled up with a female, weeks before her eggs would drop. Instead, the signal led them to a body. Loki's head and neck had been chewed away entirely, and what remained of him, roughly 52 pounds of python, had been partially covered with pine needles and debris, the way a cat caches a kill it intends to return to. That detail is what turned a strange discovery into a genuine scientific event. According to reporting from the South Florida Sun-Sentinel, which first broke the story, and follow-up coverage from the Smithsonian and Live Science, Bertashek's team initially suspected two possible culprits, a Florida panther or a bobcat. Panthers were quickly ruled unlikely. There are only around 200 left in the wild, and an encounter with one in that specific patch of swamp would have been a long shot. Bobcats, on the other hand, are common throughout the Everglades, and cats in general are known to cache food they plan to revisit. So the team did what field biologists do. They waited. Trail cameras went up around the kill site, and within days, the culprit walked directly into frame. A bobcat, weighing somewhere in the neighborhood of 25 pounds, calmly returning to feed on a snake that had outweighed it 2 to 1. To understand why researchers found this so remarkable, you need to understand what Burmese pythons have already done to this ecosystem, because the numbers are almost hard to believe. In 2012, a team led by biologist Michael Dorcas of Davidson College, working with the U.S. Geological Survey, published a study in the Proceedings of the National Academy of Sciences that remains one of the most cited pieces of research on the python invasion. The team drove nearly 57,000 kilometers of Everglades roadways at night between 2003 and 2011, counting every mammal they saw, and compared the results to surveys taken in the 1990s, before pythons had become established. The results were staggering. Raccoon sightings had fallen by 99.3%. Opossum sightings had fallen by 98.9%. White-tailed deer sightings had dropped by more than 94%. Bobcat sightings themselves were down 87.5%. Rabbits and foxes, once common enough to be logged constantly, simply weren't seen at all anymore. That last number matters for our story. Bobcats were not thriving in a python-free paradise while the invasion raged around them. They had been hit hard too. Whatever species killed Loki wasn't an unaffected bystander finally deciding to intervene. It was a survivor of the same collapse, operating in a landscape that had already been stripped of most of the prey it used to depend on. That's part of why the Loki incident, and what came after it, felt significant to researchers rather than like a one-off curiosity. It suggested that at least some of the animals still standing in this diminished ecosystem were starting to treat the invader itself as a resource. Here's where the story gets more interesting, because Loki's death wasn't the first sign of this behavior. It was the second. More than a year earlier, in June 2021, a separate USGS trail camera deployed in Big Cypress National Preserve had already caught something remarkable. A bobcat discovering an unguarded Burmese python nest and systematically raiding it, eating the eggs one by one over the course of at least 2 visits. According to CBS Miami's coverage of the footage, it was believed to be the first documented case of any Florida animal preying on python eggs, and the first solid evidence that a native species was directly fighting back against the invasion rather than simply being consumed by it. In part of the footage, the python herself returns to defend the nest, and the bobcat, clearly aware it's now outmatched, backs off before a tense standoff plays out at the site. Taken together, these two events, egg predation in 2021 and an apparent adult kill in 2022, form the beginning of a documented, if still limited, pattern of bobcats treating pythons as prey rather than only as competitors or threats. Researchers are careful not to overstate this. Bartoszek himself has been quoted describing it as a bit of a pattern emerging, language that reflects genuine scientific caution rather than the certainty of a settled conclusion. It's also worth noting the honest, less cinematic explanation for Loki's death. A cold snap had passed through South Florida in the days before his body was found. Because pythons are cold-blooded, a hard chill can leave even a large, healthy snake sluggish and unable to defend itself, cold-stunned. In biologist terms, Bartoszek's own assessment was that the temperature drop probably wasn't severe enough to kill Loki outright, but it likely left him vulnerable enough that a much smaller predator could finish the job. That doesn't make the kill less real. It makes it more explainable, and in a strange way more encouraging, because it suggests bobcats are opportunistic enough to capitalize on a python's weak moments rather than needing to overpower a fully alert animal at full strength. Bobcats aren't the only native animal that has been documented turning the tables. American alligators, the Everglades' original apex predator, have had a long, genuinely mixed history with pythons, and it's worth being honest about how mixed it is. Some of the earliest documented python-alligator encounters did not go well for the alligator. In one widely reported 2005 case, researchers found the remains of a 13-foot python that had attempted to swallow a 6-foot alligator whole. The python's body had ruptured under the strain, killing the snake and leaving both animals dead at the scene. University of Florida wildlife professor Frank Mazzotti, who has studied these encounters for years, has noted that the outcome of gator-python confrontations tends to go both ways. Sometimes the alligator wins, sometimes the python does. And for a long time scientists weren't sure the balance favored either species consistently. But more recent footage suggests alligators are increasingly willing and able to come out on top. In December 2023, a cyclist in the Shark Valley area of Everglades National Park photographed and filmed a large alligator with a python clamped in its jaws, the snake already dead, in an encounter that circulated widely online. A similar sighting was reported in the same area in 2026. Wildlife researchers who study the two species note that when an alligator does win, it's rarely a clean fight. Pythons don't tear easily, and a gator big enough to subdue one usually has to work the carcass apart over an extended period, sometimes hours. None of this means alligators have solved the python problem, any more than the bobcats have. A single gator eating a single python doesn't meaningfully dent a population that USGS estimates place somewhere between the tens of thousands and possibly higher across South Florida. But it does mean the Everglades' most established predator has not simply ceded the top of the food chain to the newcomer. If you're new to this story, here's the short version. Burmese pythons are native to Southeast Asia, and they arrived in Florida through the exotic pet trade beginning in the 1970s and 1980s. Some were deliberately released by owners who hadn't planned for a docile hatchling to grow into a 200-pound adult. Others likely escaped on their own. Then, in 1992, Hurricane Andrew tore through a python and reptile breeding facility near the Everglades, and an unknown number of additional animals were freed into the wild in a single night. Within roughly 2 decades, the mammal populations described above had collapsed across large sections of the park. This isn't just a wildlife story, it's a watershed story. The Everglades functions as a natural filtration system that recharges the Biscayne Aquifer, which the Conservancy of Southwest Florida and multiple restoration groups say supplies drinking water to more than 8 million Floridians. A collapse in the animal populations that shape plant growth, seed dispersal, and marsh structure has ripple effects that extend well beyond the swamp itself, which is part of why the state treats python removal as an infrastructure issue as much as a conservation one. Here's the part of the story that keeps wildlife geneticists up at night. In 2018, a team led by USGS research geneticist Margaret Hunter published a study examining DNA from more than 400 Burmese pythons collected across South Florida. The team was originally trying to map how the python population had spread and where it was breeding. What they found instead was a surprise. 13 of those 400 snakes carried mitochondrial genetic signatures belonging not to the Burmese python, but to a close relative, the Indian python, a species better adapted to drier, higher ground than the Everglades wetlands. In other words, some of Florida's invasive pythons are hybrids. The study's authors suggested this crossbreeding likely happened before the animals ever reached Florida, possibly within the pet trait itself, and that it may be giving the resulting population a broader genetic toolkit, greater diversity that could, in theory, make the snakes more adaptable to a wider range of habitats than a purebred Burmese python alone. It's worth being precise here, because this point often gets exaggerated online. The 2018 study documented genetic hybridization and increased diversity, not a confirmed leap in cold tolerance or a documented range expansion into new states. Separate research has explored the Burmese python's own capacity to acclimate to cooler conditions over time, and scientists broadly agree that a hard freeze remains the most significant natural barrier keeping the species contained to the southern half of Florida. But researchers are watching the hybridization question closely, because even a modest increase in genetic flexibility, compounded across many generations of a fast-breeding invasive species, is the kind of variable that can change the long-term math of an invasion. While the ecosystem sorts out its own response, humans haven't been sitting still. Florida runs one of the most unusual government-backed hunting programs in the country. Contracted python removal agents who patrol canals and levees, mostly at night, using nothing but spotlights, trucks, and their hands. The best known of these hunters is Donna Khalil, a contractor with the South Florida Water Management District, who leads a removal team known as the Everglades Avengers. Khalil caught her first python on Christmas night in 2015 and has been hunting them almost every night since. By 2025, her personal removal count had passed the 1,000 mark, according to CBS Miami's reporting on her work. She's also a consistent top finisher in the state's annual Florida Python Challenge, a 10-day public hunting competition that draws hundreds of participants from across the country. In the 2025 challenge, held in July, Khalil caught 56 pythons in the professional division, enough to make her one of the event's standout hunters, even though the overall grand prize that year went to a first-time competitor, Taylor Stanberry, who removed 60 snakes. Statewide, the 2025 challenge set a record with 294 pythons removed by 934 participants, nearly 50% more than the previous year's total. Khalil has been open in interviews about the physical toll of the work, bites, scars, and at least one encounter with a python she has described as feeling like wrestling a muscle-bound telephone pole. She's also been consistent about the philosophy behind it. This isn't about hating the animal. The python is simply doing what its biology evolved to do, in a place it was never supposed to be. Removing it, in her framing, is an act of ecological repair. Every hunter working in the state's contracted program is required to document each catch, measurements, weight, location, and reproductive status. Data that feeds directly into the population and movement models researchers use to track the invasion. It's a genuinely collaborative system. Field scientists identify where and how pythons are spreading, and licensed hunters translate that research into snakes physically removed from the landscape. The detection problem is exactly why researchers have spent the past decade building tools that don't rely on a human or a bobcat physically stumbling onto a snake. The most promising of these is environmental DNA sampling, usually shortened to EDNA. The concept is straightforward. Every animal that moves through water sheds tiny amounts of genetic material, skin cells, waste, mucus, and that material lingers in the water long enough to be filtered out and tested. USGS scientists first developed python-specific EDNA markers years ago, and in field trials across dozens of South Florida sites, the method detected python DNA in more than half of all sampling events, even in areas where visual surveys had turned up nothing. More recently, researchers at the University of Florida's Institute of Food and Agricultural Sciences went a step further, developing what they call a tetraplex digital PCR assay, a single water or soil test capable of simultaneously screening for 4 different invasive constrictor species at once: the Burmese python, the northern African python, the boa constrictor, and the rainbow boa. According to UF/FAS, the tool is designed to work across the full range of environments where these snakes now turn up, from the deep marsh to canals running through suburban neighborhoods. It won't replace hunters like Donna Khalil, who still have to physically catch and remove an animal once its presence is confirmed. But it gives wildlife managers something they've never really had: an early warning system capable of flagging a python's presence in a waterway before a human ever lays eyes on the snake itself, and a way to map which canals and corridors invasive constrictors are most likely to be using to expand their range. State and federal agencies have collectively spent more than $10 million on python management since 2004, and tools like this are aimed at making that spending go further. None of this, not the bobcats, not the alligators, not Donna Khalil's 4-figure removal count, has come close to solving the python problem, and researchers are careful not to oversell it. The USGS's own estimates for the total python population in South Florida span an enormous range, from the tens of thousands into the hundreds of thousands, precisely because these animals are so difficult to detect. A python can lie motionless in dense vegetation a few feet from a person and never be seen. That detection problem is the single biggest obstacle standing between current removal efforts and any realistic hope of eliminating the species from the region. What the Loki story and the egg-rating footage from Big Cypress before it genuinely represent is something narrower, but still meaningful. Early evidence that a badly damaged ecosystem retains some capacity to adapt. Bobcats that survived the worst years of mammal collapse appear to be finding new, unexpected uses for the predator that helped cause it. Alligators are, at least sometimes, holding their own. Whether either behavior will scale into something that meaningfully slows the invasion, rather than remaining a handful of remarkable but rare events, is a question researchers say will require years of continued monitoring to answer. For now, the lesson from that quiet, unmoving dot on a tracking screen outside Naples isn't that the Everglades has found its answer to the python invasion. It's that the swamp is not finished responding, and that scientists watching it closely may still have more surprises coming. If you want to understand where this invasion goes next, keep watching. The bobcats and alligators are only part of the picture. The human side of this fight, and the science trying to keep pace with a species that keeps adapting faster than expected, is just as unresolved.